Hello. Hello, everyone. I'm going to introduce our next set of speakers. So first up, we have Professor Zainal Kadir. Zainal is a professor at the University of Putra, Malaysia. He's also a fellow of the Academy of Sciences Malaysia and the Institution of Engineering and Technology. Currently, he is the chairman of the National Committee of the IEC TC81 Lightning Protection, and he is also an advisory board member of the National Lightning Safety Institute in the USA, a research advisor for the African Center of Lightning and Electromagnetic Network. Right, Professor Kadir, please go ahead.
Thanks, huge. So I'm going to share the ICLP. So I'm going to share my screen. Hope you can see that.
Yes, that's showing nicely to us.
Okay, all right. So within the so within about 10 minutes, so I'm trying to share probably it's going to be the latest informations, but of course subjected to, again, up to some extent that we have to agree the informations that we have with regards to the source and also to the data integrity. But nevertheless, at least this is something that we have been keeping the records for the last most probably about I would say maybe like decades or so, 15 years. But before that, I'd like to actually acknowledge my my colleague Shakura for generous enough, I mean, to prepare all these informations, and also Azliza on the GIS helping me to do some correlations. So I would say very fresh informations that we have, and very raw at some point as well. But again, for the last most probably from 2008 until June, until this month, we've been recording and again, as I said, keeping all the database with regards to the injuries and also fatalities for quite some times. And what you're going to see, or what you are seeing at your screen at the moment, most probably the latest information that we have in the countries with regards to the fatalities and also injuries. I think overall, I would say more or less 1-to-1 ratio between the fatalities and also injuries, with a total of about 300 something. And looking at the trends of the lightning fatalities, for example, most of the victims happen to be those who are doing some outdoors activities. And again, even the way we classified all these informations are based on the informations that we got from the media and also from other sources. From fishing and also aquaculture contributed second largest in terms of the percentage. We have from the the transport, with regards to the transport, whether close to the vehicles, while riding the motorbike and things like that. Recreations, indoor, some cases also happen to be at the indoor, and agriculture. So a point on the agriculture, that will be our main focus for the country as well. I think as far as now, this huge agenda on the food security, and you can see, or start to see that all of the countries, really looking into this aspect, and for that reason also, still agriculture will be one of the our main activity in the countries, but of course, not on the conventional basis, but now with the deployment of the technology. So you can see, as much as we would like to have achieve on a certain I would say perspective of improving our quality of life through the food security, but then again, we are also exposed to the potential of the natural disaster coming from the lightning. And in terms of the place of lightning fatality occurrences, so more or less we have about 50-50 between those who are in the rural and also in urban or in city area. As far as the gender is concerned, so for the last, again, I said for 2008 to 2000, June this year, so most of the cases happen to be, of course, male, and with small amount, and of course the rest you might wonder, there's no information given from the source that we have. In terms of the trends, the lightning fatalities since 2008, we can see that I think this is something that is very unique and comes to the point for which really something needs to be done, especially with regards to advocacy to the public, the safety awareness, the campaign, the education, through the campaign or through the seminars and also workshops. Because the fact that you can see the fluctuations in terms of the recorded fatalities, there's I would say there's no sign of what we call of having the fatalities or having the data recorded to be reduced. Although we might see the case in 2022 and also 2024, but again, put aside the integrity of the information that we have, so still I think there's a lot of things that needs to be done as far as the lightning safety is concerned, especially with regards to the public. And in terms of the time or period of the events, most of the cases recorded will happen, to be in the afternoon, between 12 to 6 p.m. Late afternoon, for about 70, cases, and the rest, of course, between 6 and above, and also early afternoon as well. You have also several cases recorded. From the state in Peninsular Malaysia and also in Malaysia as a whole, we have about 13 states, and you can see that in terms of the fatalities recorded, this particular state, which is denoted by the red color here, located just a couple of kilometers from Singapore, and very much surrounded by the sea water. So likewise, the state of Kedah, for instance, the second with the 10 recorded fatalities, and also Perak, for instance, recorded with 6, and you have Penang. So those states basically located very much in the west of Peninsular Malaysia, which is again surrounded by the Strait of Malacca, for which always from the data that the lightning location data recorded, we have a lot of lightning activities over there. And from the as far as when we try to compare in terms of months, because it's very interesting just to share with all of you that we have 2 monsoon seasons in Malaysia, and we also have as what we call short or intermittent monsoon. So the 2 monsoon between April to June, and also we have between September to November roughly. And you start to see like August, for instance. So this particular month is what we call the intermittent, intermonsoon season. So this is very interesting because this is very much correlated to the lightning activities that happen in the Malaysia. We have 2 peak seasons, as I mentioned, due to the monsoon, and this is very, very much, I would say, aligned to that particular monsoon or to that particular month, which is April to June, and also September to November being the August, and also March as the intermonsoon season. And this is where you will have a lot of lightning strokes recorded. I'm talking about the cloud to ground lightning. Actually, this is something that we are currently doing, And the informations that, again, you are seeing now is the fresh one. I just put the slide about 1 hour ago. And again, thanks to my colleague Shakura and also Aziza to prepare in terms of sorting all the data through GIS and also matching with all these recorded fatalities. And the intention is that at the moment I'm not doing any correlation. I'm just putting it, like very raw and try to portray it or try to have like most probably the first impressions from the area of the state, just try to see the coverage, of course, having, sometimes you may have area which is very large, but then less populations or vice versa. And also, we put the number of fatalities accordingly. So this is something that, we managed to sort the informations that we have, and also in terms of the percentage. And on the right-hand side, you see the number of strokes. So this is where we use the lightning location data that we have, and we try to clip all of this lightning stroke or the number of strokes accordingly to the state, according to the area, the kilometer square area. And you start to see, or you start to put the percentage, and start to actually, again, as I said, I'm not going to use the word correlation because there's no correlation being done at the moment. This is very raw, very fresh data. We put it side by side, and we try to look at, whether there's any sort of relation, at least, from having like the, higher fatalities and also the number of strokes. So again, I can't actually conclude, at the moment. And on the left-hand side, just to show the histogram of the number of fatalities accordingly to the state, and also the corresponding data or the curve, which is showing the number of lightning stroke. So you can see how much the number of stroke that we are facing, So this is for the data for about, 7 years. About 6 or 7 years of data. So almost 1 million of strokes that we have. Okay, so this is not flash, this is strokes. We are dealing with a lot of huge data, and this is something that allow us to really I would say deploy or utilize the GIS platform, the geospatial or geographic information system. And the intention is from what you see here, and this is something that we are now doing with the informations that we have, with all the data. So all these dotted, the blue dots over here are the data, okay, recorded for a year. So this is just a sample. And this is using the platform of GIS. And the next things that we are going to do is to have the correlation study. Using the, there are several methods, for example, the principal component analysis, PCA, just to see the correlations, and also to look into the trend and the data analysis. And one more thing that I want to highlight, that's why I was asking about the questions on the data set, because we have done some correlation study with regards to the lightning strikes and also the asset from the utility. And the correlation that we have done or we have carried out, it is trying to correlate lightning and also with other informations. For example, the precipitations, the temperature, the wind, the elevations, and also the pressure. So almost any single informations or any data that you have, you can do some correlation study using this GIS platform. So this is the beauty of that, and this is something that we have gone through for the last 6 or 7 years, using the GIS to do more data analytics sort of. So I think huge over to you. I think this is very quick, sharing. The latest trend is unpublished informations. like first-hand info, just sharing with all of you in this community. So I think with that, thank you very much for your time, and happy to answer any questions if you have. Thank you very much. Over to you, Rish.
Yes, I think my question was, it would be interesting to start looking at how, rather than stroke density or ground flash density, but how ground strike point density relates to fatalities as well. So less of a question,
Correct.
more of a comment. But I think Chris will
Yeah,
also
yeah.
discuss this later as well.
Yeah, of course. I think that's valid point as well as being in the IEC. But then again, I think it's much better to have this at least now with the stroke density, because the earlier sort of not version but data that we have very much on the flash, and even within a single flash you may have several strokes, and that's why I think by using at least the stroke indicators, that is very much relevant and also accurate, especially in terms of the.
Right. Thank you, Zainal.
Okay, thanks. Yeah.
Okay, our next presenter is Sitti Jannah Ismail. Sitti is a first-year nursing student at the Cebu Normal University in Philippines, and she'll be presenting her capstone high school research. So, Sitti, you can go ahead and start your presentation there.
Thank you, Hugh. Let me just find. Okay. Once again, I would like to thank you for the very brief introduction, and I would like to give my special thanks to Dale Zhang for the privilege of. Wait, hold on, wait. Oh yeah. Again, thank you to Dale Zhang for the privilege of participating in this very significant event. A pleasant afternoon, morning, or evening to every one of you from the Philippines. Again, I am Sitti Jannah Ismail, and I will be presenting to you my high school capstone project while I was still affiliated with the University of San Carlos, entitled Lightning Fatalities in the Philippines from 2006 to 2021. So, to begin, studies on spatiotemporal distribution of lightning fatalities and injuries have grown over the past decade. Yet, they primarily focus on developed countries due to robust data like the storm data. Despite high lightning activities, the tropics lag in research, particularly in developing countries such as the Philippines, which has one of the highest lightning flash densities globally. Now, limited studies exist mentioning the Philippines, addressing specific sectors like agriculture and fishing, as seen in papers made by Hall in 2010, 2016, and 2021 to the best of our knowledge. However, they lack comprehensive nationwide summary. Thus, this study aims to fill that gap by analyzing the spatiotemporal patterns of lightning incidents in the Philippines to enhance public awareness and safety. That is the significance of this study. Now, with that, we have 4 objectives, namely, 1, to calculate the frequency of lightning fatality cases, 2, to deduce the diurnal and seasonal occurrence, 3, to map out the cumulative spatial distribution using QGIS, and lastly, to determine the demography of the lightning fatality victims. Now, in order to achieve that, we need to first understand the geographical profile of the country. The Philippines is an archipelagic nation with diverse topography and 2 distinct seasons, which are 1, wet from June to November and dry from the months of December to May. Now, according to the 2020 census, it has a population of 109 million, with a quarter residing in highly urbanized cities, or HUCs in our paper. Now, you might be wondering, how did we collect the data? Well, the data on lightning fatalities were collected from online news sources, which we have gathered using Boolean search operators, and the majority from the Philippine Statistics Authority, or the PSA, via the Electronic Freedom of Information. The PSA database includes information in the year, month, locality, age, and sex of the victims. At the same time, online sources provided additional details such as the time of the event and the victim's activities. Additionally, population data was sourced from PSA and macro trends. Now, these collated data is then analyzed using descriptive statistics, which were adapted from previous studies of Lamini in 2009, Zhang et al. In 2019, Cardoso et al. In 2014, and Hall et al. In 2019. Now, as for our results, from 2006 to 2021, the PSA recorded 1,584 lightning fatalities, averaging a 1.01 fatalities per million per year. Now, a decline in fatalities was observed from 118 per year from the years 2006 to 2013 to 80 per year from the years 2014 to 2021, which is evident by the decreasing trend line. Now, the highest fatalities was observed in 2010 and lowest in 2019. Now, according to Cooper and Hall's classification in 2019, the Philippines' average annual lightning fatality rate of 1.01 per million is classified as intermediate, comparable to other developing countries. The decline in fatalities is likely due to the reduced agriculture employment and better accessibility to safety information through media and disaster alerts, according to Briones 2017 and Tabuga et al. In 2022. Now, lightning fatalities peaked between the months of May and July, accounting for over 56.7% of all incidents, with May being the highest. As you can see here, the color white signifies that there were no fatalities recorded in the month, which gradually darkens to yellow, orange, and peaking at red. In this picture, you can see that the months of May, June, and July contains the most recorded fatalities, which is significantly in contrast to the months of January to April, which had the most color white and light yellow. Now, diurnally, most incidents occurred in the afternoon, particularly at 1700 in the afternoon, and little to none in the morning and evening. It is important to note, however, that this data has been taken from only 66 lightning fatalities out of the 1,584 provided, as the information were unavailable. Seasonal patterns in fatalities correspond with the lightning activity, peaking during the transition from dry to wet season and least during the dry months. Now, provincial areas accounted for 95.83% of fatalities, particularly in the northern and central parts of the Philippines, where the majority of the livelihood is agriculture. Thus, regions with high agricultural employment reported more fatalities. On another note, the highest lightning fatality rates were noted in provinces or rural areas compared to those in highly urbanized cities. Now, rural areas had higher fatality rates due to less lightning-safe infrastructures compared to urban areas. Additionally, indigenous knowledge and reporting gaps may also explain the lower fatalities in the remote areas. Now, to answer our last objectives, we have our demographics. Here in the y-axis is the age group of all 1,584 lightning fatalities, whereas the colors signify the sex. The blue indicates male and the green female. Of the fatalities, 81.89% were male, with the highest number in the 20 to 29 age group. As you can see here, it's peaking here at the age group of 20 to 29. And males aged 20 to 29 had the most fatalities, while females were mostly affected between the ages of 10 to 19. The predominant proportion of male fatalities in the Philippines can be likely due to the greater labor force participation of males in both agriculture and service sectors, according to Briones 2017. This is comparable to findings in other countries, according to Raga et al. In 2014, Sinch and Sinch 2015, and Hall et al. In 2019, where a higher number of men working in agriculture and other outdoor labor-intensive work has been the plausible factor contributing to the increased number of lightning fatalities among males. Additionally, unsafe sheltering and practices and other outdoor activities during thunderstorms also increase the risk. Also, according to the news reports that we had gathered, most victims were seeking shelter from the rain in non-enclosed structures, followed by those engaged in farming or herding and fishing. Now, from those online news reports that we had seen or we have gathered, 97 fatalities occurred in 39 multi-casualty events, the largest being 6 fatalities in Negros Occidental, which is located in the central part of the Philippines. Now, in summary, the database revealed 1,584 lightning fatalities from the years 2006 to 2021, with an intermediate average fatality rate. Males, which are 4 times more than females, and individuals aged 20 to 29 in rural areas are more susceptible. Fatalities primarily occur in the afternoon, particularly in 1700 during the rainy season, especially in the month of May. Most victims were seeking shelter from the rain in non-enclosed structures, like huts and sheds. In the Philippines, the average lightning fatality rate over the past 16 years is 1.0 per million per year. Thus, public awareness and safety measures targeting at-risk populations are essential for reducing lightning-related fatalities in the Philippines. And we also encourage that we should also efficiently collate annual and accurate data for various researchers and purposes in the future. And that is all. Thank you.
Thank you very much, Sitti. Right, have we got any questions from the floor? Wait a bit. I see Prof. Ryan Blumenthal has just made a comment saying 15 years of research. That is quite a lot of lightning fatalities. Any other questions, comments? Ryan, do you want to ask your question? Can you turn your microphone on?
If you can just see that last slide again with the amount of fatalities, please.
Okay, can you just direct me to which slide? Just tell me when to stop. Here.
It's the second last slide. Sorry.
Second. Wait.
The next second last.
Oh, second last. I'm sorry.
The summary. Yeah, summary of slide.
Okay.
There we go. A total of 1,584 lightning fatalities in 15 years. Isn't that a bit much? Is that number? That number looks a bit high.
Small?
If there's only 1 per million.
Oh, high.
Yeah. What do you think of that number? That's quite a lot of fatalities.
Yeah, like considering that when we were looking at like the news reports and as well as the data, we were kind of like thinking that it was still kind of like considered with the, like, what you call this, when we compared the online news reports as well as from the data that we collected from the PSA, we're sort of like thinking like maybe like they, what you call this, they underestimated the record. And I just believe like it coincides with the development like of the Philippines as like a society, whereas like from 2006, I guess I could say that people were less less informed of like their surroundings, but most especially with lightning, because I don't think they consider it as dangerous as typhoons, because typhoons are much more frequent here. But when we were as we were gathering the data, we just thought like, oh shoot, there's actually a lot. And I just believe that as years pass by, we hope to encourage more Filipinos and other citizens that reside here to be more informed about lightning. It's like, in a way, lightning is more of like, compared to typhoons, they're more of like underrated in a way, like in Gen Z terms, that not really people think of it as important to like avoid. So yeah, hopefully this 1,584 for the last 16 years would be much lower. Just
thank you. Yeah,
it
looks like combined data from maybe typhoons and lightning, but I think it's very high for lightning just per se. Thank you.
Yeah, thank you.
Great, thank you. Any other questions there? Here's the question in the thing from Bryce saying, do you think the general alert systems in the Philippines have helped you?
Yeah, actually, like I said, people give much more importance with typhoons, which also coincides or relates to like lightning in a way. And here in the Philippines, like especially if what you call it, the NDRRMC, the organization, thinks that the typhoon is really strong, they give out alerts, which also helps us to navigate like, oh shoot, like it's a thunderstorm, like we should stay at home. And they give out alerts, like they have like the red, the orange, I believe, and the yellow. But yeah, basically they have like the symbols like to tell us like, oh, what's the level of the like how dangerous the typhoon is, which yeah, hopefully yeah. But I think like in summary, yeah, I do think that general alert systems in the Philippines have helped me, like especially with us people being in our phones most of the time.
Great. Thank you very much, Sitti. In the interest of time, I think I'm going to close this presentation. Thank you very much, and we hope to see more
Thank you.
work. Right. Our next presenter is Mr. Kumar. Kumar is an electrical engineer having 30 years of experience specializing in safety, standardization, and legal requirements of electrical installations. He is the managing director of Cape Electric in Chennai. He has carried out more than 1,000 training events and over 100 accident investigations in several nations. He's also the president of the National Federation of Engineers for Electrical Safety, a non-profit organization working on electrical safety. Gopa, please go ahead and.
Yes, thank you very much, Mr. Yu. I think I can share the slide. Yeah, I didn't make any big preparation. I hope the slide is in full swing or it's a house.
Yes, if you're seeing it on our side. No. Okay.
I think there is some small mistake happened. Okay, screen. Oh, yeah,
yes.
now I got it.
Okay, there we go. We've got it.
Thank you very much. Thank you for all friends. Thank you for inviting me for this small short presentation. In fact, last few weeks I was running all over India for several of my activities, so I could not prepare a good presentation. Sorry for that. So I will try to manage with a very simple explanation. So the subject which is given to me is about the standardization in India. As all of you know, the international standards 62305 part 1 to 4 2010 version has been introduced or has been adopted in India as the national standard. But once when it be adopting a standard in the country is I would say quite simple, but following it in meticulously by the engineers is a very tough job. Most of the time, more than following a standard properly, misinterpretation or diverting the standard according to the convenience is more often in our country. Once when we come to the engineering part of the standards, for example, the part 1, all of you know that the 62305 part 1 talks about the general principles of lightning. And now in this, we have been investigating several good quality lightning protection system, and there are failure also we were analyzing. And one question which we really started thinking is the standard classifies about 5% of lightning approximately as positive lightning, and about 95% of lightning strikes as a negative lightning strike. And the rate of change of current, of course, the energy is much more in the positive lightning strike. So the sizing of the sizing or strength of the lightning protection system is made based on the positive lightning strike. But sometimes we often miss the rate of change of current, the di by dt, which is happening during the negative lightning strike. So the failure of electronics or the flashovers are quite common in most of our system. Even though lightning protection system is installed in a very good way, but still there are chances of electronic failure. This gives us an idea that whether the lightning strikes, negative lightning strikes, are more in our area or not. I also would like to listen to the other experts whether if anybody have data on the number of lightning strikes, positive versus negative in tropical areas. So when it comes to part 2, risk assessment, the standard is implemented, but the problem which we face is the non-availability of latest data on number of thunderstorm days or lightning flash density. This data is, of course, several organizations are publishing data, but most often the data are in conflict. As a result, in the standards committee, we are unable to take some data as a concrete data for the country, but we are still trying to get some data on this particular, the lightning flash density. When it comes to the part 3, physical damages to structure and life hazard, most often the challenges which we face is the routing of down conductors, challenges in separation distance, keeping the lightning protection away from the building. Most often this is very risky. Architects will not agree, the engineers will not agree. Also, the equipotential bonding. This is also often missing in most of the lightning protection installed in the country. When it comes to the part 4, the major issue which we face is the length of the SPDs, the wire, the length of the wire which is used to connect the SPD. As a result, the efficiency of SPD is quite less. We are putting a lot of effort to educate about these points in the market, but the acceptance is very slow. Probably due to the size of the country, we have the population of our country, the size of the country, and the number of people those who are working in the field is also quite less. In 2015, the international standard has been adopted as IS standard. So the dual numbering IS/IEC 62305, all the part 1 to 4 are being adopted. Now we are on the job of making the 62561 part. These are the components which is used in lightning protection system. These standards are being adopted. It is under preparation. The drafts are under wide circulation. Probably in next 6 months we will have this series of standard also as Indian standard. Also, when it comes to the human and safety and human protection, all the 3 IEC technical reports as well as standards are being adopted as Indian standard. The IEC TR 62713, safety procedure for reduction of risk outside structure. This is adopted as IS/IEC TR 62713. Similarly, the IS/IEC 62793 thunderstorm warning system and IS/IEC 62858 lightning density based lightning locating system. These standards are also adopted as Indian standards. So basically, the standard making process is very strong now. We are very soon adopted to the standards. But the biggest challenge which we face in the practical execution is the non-standard lightning protection system. The concentration of these systems are very common in India. We have even written as this non-standard system. It's very clearly we have put in the National Building Code as this shall not be used, but unfortunately it went for a big litigation. There was court case, and finally we won the case, and the non-standard systems are no more legal in India, but still a majority, 95% non-standard systems are used. This is about a short introduction about the standardization activity going on in India. Thank you very much, Mr. Hamid.
Great. Thank you very much, Gopa. Has anyone got questions there? Just a question from my side. Do you have any in South Africa here? We've always had a document which is a South African standard, but it doesn't superimpose 62305. We adopt the 62305, and then we have the standard just highlights one or two things that we feel are relevant to the South African context. Do you have something similar in India out of interest?
Yes, we have something for specific for our construction, our type of construction. This is not mentioned in the 62305. We have one more document which is the National Building Code of India. So we addressed those issues specific for India in the National Building Code of India.
Okay. Oh, interesting. Thank you. Any other questions for Gopa?
So thank you very much. Thanks to
Yeah.
all.
Thanks for your presentation.